Hi guys, today in this video we're going to look at the basics of electrolysis. What is it? How does it work? Things like that. So the first thing we need to understand is what an ionic compound is, because if we don't understand what an ionic compound is, then we don't know how electrolysis separates it. So hopefully you looked at one of the other videos and you know that an ionic compound is formed between a metal, which is usually positive, and a non-metal, which are negative. And when they form, the metal donates its electrons to the non-metal and the non-metal receives the electrons, and they form electrostatic forces between those two ions which hold the ionic lattice together. That's usually a really strong bond, but we're going to look at how we can separate that with electrolysis today. Now, electrolysis uses electricity to separate this compound. So we pass electricity through a solution called an electrolyte. And that solution, or an electrolyte, is a solution that can conduct electricity, something that allows electricity to pass through it. And in that electrolyte is usually your dissolved ionic compound, but not always. Today we're going to look at molten. What happens if you take an ionic compound and you melt it using heat? So we're going to look at two types of electrolysis, molten and aqueous. Aqueous will be for a different video, and today we're just going to look at the basics and touch a little bit on molten. So electrolysis, as we just said, breaks down these ionic compounds with electricity. Now, once you've got these free-flowing ions, they will naturally move to oppositely charged species, and we call this the electrode. Now, we'll have a look at this as a picture now. Before we can actually do that, we'll have to think about what the keywords we're going to look at and talk about in this video. So we've got some keywords down the left here. We've got electrode, cathode, anions, cation, electrolyte, and anode. Pretty tricky, complex keywords. Now, you won't usually have to use anode and cathode. This is more for higher tier and triple. You're more than welcome to call them positive and negative electrode, but I thought I'd include them just for those people who may need to use them. So we've got some definitions on the right hand side, and we'll have a look at which ones they match to. So electrodes, as we just talked about, these are usually rods within the electrochemical cell, and they're charged. They're usually made of something like carbon or graphite. And the ions move to the electrodes. So we're going to say electrodes are a rod that attracts ions. Now the cathode, in the brackets there you can see is negative. That's the negative electrode. It's the electrode that attracts the positive ions, because remember, opposites attract. Then you've got anions. Anions are negatively charged ions. You're fine to just call them negatively charged ions. You've got cations, which are positive ions. You've got electrolyte, which we've already visited already, which is the solution that allows electricity to flow through it. And then finally, the anode, and these are the positive, or attracts the negative ions, the positive electrode. So I'll leave that on the screen for a second, and hopefully you can see the keywords and the definitions next to each other. And these are something you're going to have to keep coming back to, so when I use them in this video, you know what they mean. This is a very simple diagram of an electrochemical cell, or an electrolysis setup, and we're going to start labeling what it would look like, or what the different parts are. So we've got this bit in the middle here. Hopefully from physics, you'll know that that is a cell. Can also, if there was multiple of these, be a battery, but you can call it a cell or a battery. In chemistry, it won't be that picky usually, but we're going to call it a cell. This is where the electricity comes from, and then it flows through the wires, and you've got two types of electrodes. So this is an electrode. We're going to say that this one is the negative electrode. And then the other side, we're going to have the positive electrode. Then in the center here, the solution is called the electrolyte. And that's really all there is to it. But what we can do is start to put some real world examples into this to see what would happen. So for instance, we're not going to bother about the cell or the electrodes just yet. I'm going to say that my electrolyte, or my ionic compound for this particular example, is going to be lead bromide. Now lead bromide as a formula is Pb for lead, Br2. And the reason it's Br2 is because lead is a 2+ ion and bromine comes as a minus ion. So I need two of those to cancel out the 2+ on the lead. So if this was to break down in solution, to be dissolved, or to be melted, I would have these ions. I would have 1 2 plus for my lead, and I would have 2 Br minus ions. Now, if you don't know why they are forming these ions, and I suggest you look at my previous video on ions where we go through this in much more detail to see how we work out if something is 2 plus or 1 minus. So now we know that we've got a Pb 2 plus ion and we've got 2 bromine minus ions in here. We can work out where they'll go to. Now this is the easy bit. We said before that this is the positive and this is the negative electrode. Well, the positive ions will move towards the negative electrode because opposites attract. And the negative ions will move to the positive electrode. Okay? When they get there, something happens. They become discharged. They lose their charge by either gaining or losing electrons. So we can have a look at that. Let's look at what happens when the lead goes to this electron here. And as you probably, if you've seen this before, may know, this is something called the half equation. I'm going to do a separate video on this. This is only to illustrate what actually happens when we get to the electrode. So you're going to have Pb. Now Pb is lost 2 electrons to become 2 plus, and it will gain those back when it reaches that electrode. So it will gain 2 electrons and it will become lead as a solid, just lead. At the other side here, we've got bromine. Now each bromine ion has an extra electron, Br minus. Now they will actually lose their electrons to become bromine gas. So remember, bromine and any group 7 element is diatomic. So when that forms the electrode, it will go back to being diatomic. It will be Br2 or H2. I know it's not group 7, but you get the idea. So it will be diatomic when it's formed. So that's all there is to it when we're looking at electrolysis. Let's try another one. We've got a couple here. We've got potassium bromide and copper chloride. I'm going to give you the formulas. Then you can pause the video. You can try and work out the ions and what will be made at both the cathode and anode if you like. But I'll start writing the formulas for these. So we've got potassium bromide, which is just KBr. And we've got copper chloride, which is CuCl2. So pause the video, have a go at this, then we'll see you go through the answers. So the ions for potassium bromide, we have K plus and we have Br minus. Now, if you remember, opposites attract. So if you remember the cathode, now cations go to the cathode, so the cathode is negative, and anions go to the anode, so the anode is positive. So we've got a K plus here. Where's that going to go? Well, it's going to go to our cathode. But we don't form ions at the cathode, we form elements. So something must happen to this potassium for it to become an element. So the potassium, the K plus, gains an electron to become potassium as a solid. And the bromine, well, if you remember, bromine should lose an electron to become Br2, to become diatomic. But we've got a problem here. We started with 1 Br minus, but formed 2 bromines when they bonded, Br2. So we need to balance this. Now again, I'm going to do a separate video on half equations, but just for completion, I'm going to show you how it's done. You need 2 bromine minus ions to form the 2 Br here that's formed, which means 2 electrons will be released overall. We could then go back and balance this formula if we wished, and I'll show you that in a separate slide. Copper chloride. Well, copper chloride forms the ions Cu2 plus and 2Cl minus. Remember, you've got a little 2 here, so that means we've got 2 Cl minus ions. The copper will go to the cathode, and that will gain 2 electrons because it's a 2 plus ion. And there you'll have copper solid forming. And on the other side here at the anode, you're going to have your 2 Cl minus ions, both losing an electron to form chlorine gas. So as I promised, here's the answers to those. Bit clearer there, you can see it hopefully, better than my scrawly handwriting. But that's all there is to the base of electrolysis. Just knowing what the keywords are, how do they link to a diagram, that's your foundations here. Then moving into these last couple of slides where we're looking at the types of ions and what's formed at the electrode, that's the top end of foundation tier and pushing into higher tier. In the next two videos, we're going to look at molten in more detail as well as aqueous. Now, these are the more tricky parts of the chemistry behind electrolysis, so well worth a watch. But thank you for watching today and see you soon.